Regular biology. Monday, March 30th, review of Punnett squares, pedigree, and karyotypes. Your genetics study guide will be assigned today. You can choose to do it today, tomorrow, or Wednesday. I will have a help session on Wednesday at 11 a.m. For those of you that are struggling with the study guide, not sure what's going on, and I will include both 5th and 6th hour will have the same code. So 11 a.m. If you have some questions, you just put them up there and type them in the chat, and I'll respond to them. It shouldn't take long. I don't anticipate that taking over 15, 20 minutes maybe, unless somebody's really struggling with it, and then I can certainly go through and explain some other things. I will give the answers to anybody else later on that day, and then again I'll give the code out on Thursday for that genetics test, and you can figure out when you want to take it. But once you open it, remember you only have a set amount of time, so plan about an hour for that. So again, this video will be about 20 minutes, maybe 15, 20 minutes. Your study guide will take you about, I don't know, maybe an hour. So now we're an hour and 20 minutes in. The test takes you hopefully another hour. So again, I need you to log about 3 hours in for 5 days. I think you guys can handle that. You know that Friday you show up, we talk shop real quick, and then we're out the door. That's just a day of attendance to make sure I can count you present, and that's it for Friday. So if we look, let's go back to what we know about Mendel. Mendel got lucky. He studied garden pea plants. They show 7 distinct characteristics, and they show complete dominance. Remember, Mendel thought like some of you thought. I got these tall plants, I got the short plants, I should get something in between. Wasn't the case. Pea plants show complete dominance. It's either tall or short, one or the other. Okay, then he came up with 2 terms, dominant, recessive. If we look at this one, remember, we talked about a red flower crossing with a white flower. I get a blend. I get a pink flower. That's a blend. That's incomplete dominance. That's an example of incomplete dominance. Probably going to be on the test. Red, white, get a pink. Okay, over here I got my black rooster, my white hen. I get a speckled chicken. I don't get a gray chicken. A gray chicken would be a blend. This isn't a blend. This is showing both alleles, both the black and the white are being showed, okay, or being shown here. So that is codominance. Incomplete dominance, blend. Codominance, you see both, okay? An example, this would be like hair, curly hair, straight hair. Over here would be like blood type. AB is codominance, okay? So now let's go to what Mendel. So a guy came up by the name Punnett came up with this Punnett square. The Punnett square is a tool used to calculate probabilities. All right, so what I proposed, I gave you the 2 parents. Little h crosses with big H, little h. What is the probability of their offspring having Huntington's? Think back to the essay. You read an essay, it had 2 disorders, Huntington's, cystic fibrosis. Huntington's is an autosomal dominant disorder. That means if you have the big H with the little h, you've got it. You're not a carrier. No, not in this. You have it. If you have big H, you have it. It's a dominant. If you have big H, little h, you have it. It's a dominant. Only way you don't have it, you would be normal, is 2 little h's. Everybody sitting in my classroom has 2 little h's. This is pretty rare in this day and age. Now, I would have to tell you, I'd say, hey, this is one of the test questions. What gametes can you get from this? Well, I can get a big H or a little h. What gametes can I get from here? This. I can get this H or this H. So when we write the gametes for those, they look like this. We're just taking this gamete, and that's where we're going to hear the term gametes. And now we drop them in. If it's big, we put the big one first. If it's 2 little ones, doesn't matter what order we put them. And then we fill it in. So it looks like we have big H, little h. Okay, yes, no. Yeah, you have Huntington's. Big H, yes. Little, that would be normal. So what's the probability? 2 out of 4, that's 50%. Now we go to the second one we were reading about, cystic fibrosis. It is a recessive, right? Autosomal just means it's dealing with one of your non-sex chromosomes. Autosomal. Remember, your karyotype, you have 23 pairs. That gives you 46 total. Keegan, my little guy, has 47. That's why we had him in to visit with you. Autosomal recessive. Again, autosomal, you have 22 pairs of autosomal chromosomes, one pair of sex chromosomes. If they asked you for total number of autosomal, you would have 44. So some terminology that you gotta understand. When I say autosomal, you just know it means non-sex, dealing with the non-sex chromosomes. Recessive means the only way you can get a recessive is if you have both alleles, both little c's give you cystic fibrosis. Now, if I look up here, our parents are heterozygous. Remember that terminology? Heterozygous. And what gametes? Yeah, that C here, that C here, this C here, this C here. Now we put them into our Punnett square. Cystic fibrosis, yes, no. Cystic fibrosis, yes, no, no. Now this is a carrier. Both of these were carriers because it is a recessive disorder. Now, how many have it? How many of the offspring have? That one. It has both the little c's. The only way you can get a recessive is have both little c's. That's 1 out of 4. That's 25%. So now we've looked at a autosomal dominant. We've looked at an autosomal recessive disorder. You know you're going to see them on the test. Now, sex-linked. We read the activity, gifts from your parents. The Tsar Nicholas II, he didn't have hemophilia. His son ended up having, young Alexis, the heir to the throne, had hemophilia. Not good. You're probably not going to live back then in those days with hemophilia. The mom didn't have it, but she had the ability to pass it on. She was a carrier. So if I look at the mom, Alexandra, she had a big H, little h. The dad didn't have it. Now again, mom can bring this one, this is gamete, or this gamete. Dad, this one, or this one. Who controls the gender of the offspring? Dad does. Dad does. He's the only one that can bring a Y to the party. We put it in the Punnett square. Boom, boom. Female, because it's XX, big H, that's normal. Female, XX, big H, little h. Carrier, but doesn't have it. Normal. Male, XY, doesn't have it. Male, XY, with a little h, has hemophilia. So again, sex-linked are more common in males because they only have one X chromosome. Females, you could get it, but again, it's a recessive disorder, so you would need to have both of them to be expressed. This is heterozygous. Female doesn't get it. That's a sex-linked. That means they're linked to the sex chromosomes. The other two were autosomal, not linked to sex chromosomes. On the 23rd, 2 days after National Down Syndrome Day, I put a karyotype on there. I put Keegan's up, and then I gave a couple examples of like Klinefelter's, Jacobs, and Turner syndrome. Okay, so if we look at this one, I talked to you earlier in this presentation. It says, is this karyotype of a human? I said that you have 22 sets, 22 pairs of autosomal chromosomes and one pair of sex chromosomes. Is this human? This has 16 with one pair. Not human. 16 is not. This should be if this were, this would be a 22, that would be your 23rd, that would be a human. Not human. It says number 2, what is the gender of this organism? Pretty easy, we just talked about that. We have an X and a Y, therefore it's a male. And number 3 says how many karyotypes, how are karyotypes arranged? So if I look and I remember back, I get 23 from mom, 23 from dad. The largest one from mom meets up with the largest one from dad. The second largest one from mom meets up, and so on. So again, from the largest to the smallest. It says how many total autosomal chromosomes, not how many pairs, how many totals. We're going to have to do some counting. We count all the autosomal ones, so we don't count the sex chromosomes, all the other ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. How many autosomal chromosomes? 33. 2 sex chromosomes. Next up, how many total, are there any chromosomal abnormalities? Got to work on my reading skills here. So if I look for abnormalities, you should get 1 from mom, 1 from dad. I look at this one, the first pair, I don't get a pair. So normally I would have 1 from mom, 1 from dad, 1 from mom, 1 from dad, 1 from mom, 1 from dad. Here I'm getting just 1. This would be termed monosomy 1. And it does happen by non-disjunction. You just got the one that didn't have anything. Okay? Over here I counted 1, 2, 3. That's not the norm. It should be 2. Instead now I have trisomy 13. And then I go down to 16. Again, 1, 2, 3. I have trisomy 16. So we have a total of 3 chromosomal abnormalities. Our last thing we're going to talk briefly about are karyotypes, and then I'm going to let you go. And my expectation is that you have these or have an example in your journal. You're going to see these on the test. You're going to have to know how to read them, and I can change these, guys. Don't think that just because I have that example, it's absolutely the same, because I will fill in the circles and stuff. Remember when we left before this break, we talked about male, female. A circle represents a female, a square represents a male, a filled in circle is an affected female, a half circle is a carrier female. So again, unaffected, affected, carrier with the male, unaffected, affected, carrier. If we're talking about cystic fibrosis, remember, it's not sex-linked, it's cystic fibrosis. That means to get it, you have to have a little c, little c. To be a carrier, it's a big C, little c. Not have it all, big C, big C. So it says, what is the genotype of the following individuals? Generation 2, individual 5. Generation 3, individual 6. Generation 4, individual 3. 1, 2, 3, 4 generations are shown in this pedigree. Generation 1, 2, individual 5. Doesn't have it. It's not a carrier. Big C, big C. If I go to generation 3, 1, 2, 3, individual 6, is a carrier. Big C, little c. And then I go down to generation 4, 1, 2, 3, 4, individual 3, has it, little c, little c. It then says calculate the percent of female carriers in the female population. So again, be careful of the terminology. Only female carriers, only in the female population. Let's see how many female carriers. 1, 2, 3. Out of the female population. So I have 3 that are carriers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 3 divided by 15. I go to the next one. It says list the number of siblings in generation 2, 3, and 4. They're going to be bracketed. Not a horizontal line. That's marriage. Bracketed. So if I look at 2 here, I'm looking for siblings in generation 2. 1, 2. There's a bracket. 1, 2. There's another bracket. 1, 2, 3. I go to generation 3, a bracket again. 1, 2, 3, 1, 2, 3, 4, 1, 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 total in generation 3. In generation 4, 4, 5, 6, 7, 8. Number 4 says how many marriages are shown in the pedigree. Marriages are those horizontal line. That is a marriage. 1, 2, 3, 4, 5, 6, 7. I see 7 total marriages in this pedigree. And 5 says calculate the percent of affected males in the overall population. So that's all the people, but only males. Affected males have to be colored in square. 1, 2, 3, 4, 5. 5 divided by total number. 11 and 11 is 22 plus 8 is 30. 5 divided by 30 is going to give me that percent of affected males. So again, are some of these going to be the same? Absolutely. It just shows me that you read or watched the video here. And remember what we went through here. So we basically went through a little on Mendel, studying pea plants, 7 distinct characteristic, complete dominance. Came up with dominant allele. We went through some that were, right? Incomplete dominance is a blend. That's the term. Codominance is where you get both the black and the white being expressed in a kind of a checkered pattern. We then went through monohybrid, autosomal dominant. There's a dominant genetic disorder, Huntington's. Cystic fibrosis, recessive genetic disorder. It's going to ask you that. And then we talked about sex-linked. Hemophilia is a recessive sex-linked disorder. It's going to ask that on the test. We then talked about a karyotype. We talked about autosomal. There are 16 pairs of autosomal. Okay, but then there's a total number too. To get the total, you count every chromosome. And then you have a pair of sex chromosomes. And then we talked about a pedigree. We talked about females, males, affected, carrier, carrier. And then we did some probabilities, calculating percentages. Hope that helped out. If not, I'll see you guys, some of you guys, I will see on, what day did we say? Wednesday, 11 a.m. I'll give you a code at about 10:45. You can choose to log on if you want or not. If you log on right away, I'll give you the answers to the study guide. If not, I won't give out that answers to everybody until maybe Wednesday evening or something. But I will get you the answers out there. I would appreciate it if you'd log in for 2 minutes and I see your name there. I'm going to throw the answers your way or give you some test answers that are going to be on the test on Thursday. Have a great week. We'll see you either Wednesday or Friday.